reforming your morale or your morals. So we've changed it from that problem, how do you circumvent for every page, to how do we learn about a working bridge? How do we circumvent the firewall once, and then we can figure out a bridge, and from there we can use that bridge from then on and have an automated anonymity circumvention system. Okay, and I'll get back to details of how we learn that first bridge. But a brief interlude, which I'm going to mostly skip over, hiding Tor's network fingerprint. So right now we do two protocols on the wire. One of them is HTTP for fetching new directory updates, and the other one is HTTPS or SSL for actually connecting between two Tor servers. So the HTTP one is a really bad move in terms of being filterable, because we go to a certain place and we say get/tor/server/something or other. And for all those people out there who are good at filtering URLs, you can guess how easy that is to filter. And quite a number of different proxy filtering tools have gone ahead and done that as a feature for keeping Tor users off their network. So that's step one. We need to get rid of HTTP, and we've already done that for the most part. Basically, the way it works is if I want to fetch a directory from some mirror, I'm going to do a Tor connection to that mirror, and then inside that Tor connection, I'm going to do a fetch. I'm going to ask for the directory. So in fact, Tor still thinks of it as HTTP, but it's tunneled over the TLS connection we've already got. So that leaves us with one question of how do we do this TLS connection in a way that nobody minds, in a way that it doesn't look any different from any other web connection. And the first answer is don't put it on port 9001, which is the default. Make it default to port 443. And now you really do look like a web server. And then make the TLS handshake look more like actually talking to a web server. And then the really hard part of this is when I talk to my bank using SSL, I sort of send a few packets back and forth, and then I click and I send some stuff, and then it sends stuff to me, and then I hang up. That's not what a long-term Tor connection looks like. A long-term Tor connection looks like whatever protocol you're doing inside of it. So if we get to the point where our attackers are actually looking at every SSL connection and saying, that one looks fishy, it's been going on for a long time, and they keep sending stuff back and forth, then we're back to an arms race that's going to be a bit tough. On the other hand, since a lot of people use keep-alives and stuff inside their SSL connections to their bank, then maybe we've got a chance. But I'm going to skip over most of this. Feel free to ask me about it later on. Okay, so we talked about the relay component so far. The bridge relays are what we need to change about Tor's relay component in order to actually add some blocking resistance. Now let's think about a better discovery component. The discovery component for Tor right now is there are 5 directory authorities out there and you go talk to one. That's not so good for blocking resistance. So the great thing about Tor's design is that it's modular. You can take the relay component and the discovery component and you can build different ones and mix and match. So we can use any discovery component we want. That's great, except there aren't any perfect ones. It's always going to be an arms race. But at least from the previous slide, we've changed the problem from how do I keep 1,000 public IP addresses out of the hands of the Chinese government, which seems like an impossible problem, to now I have 40,000 IP addresses. How do I give them out one at a time without letting the bad guys learn all of them? And that's also a challenging problem, but it's a little bit more manageable. It's an arms race that I'm hoping I can actually handle. So the first question is, how do you bootstrap the first time? You gotta be able to talk to something the first time, because whatever that something is, they're gonna block it and then you lose. So our answer is, I hope you can bootstrap. Users are already getting around the firewall in all sorts of ways. You can SSH through most of these firewalls. You can find an open proxy, instant messaging. There are whole communities of people who SMS themselves, their friends. Hey, I found a new proxy. This is the one. There are people who use Skype, voice, and data. There's a whole community in World of Warcraft of people. They don't actually play the game. They just connect and sit around talking about new proxy servers they've found. So there are a lot of communities already for people who know how to get around the firewall, and we're going to leverage that just for the first step, just until you get your first bridge. They know how to get around it better than I do for whatever situation they're in, and hopefully that'll be the first step. And if they don't know how to do it, I hope they know a friend who knows how to do it. And if they don't have any friends, then maybe they should get some. Okay, so step one for discovery. No central point is a bunch of different, totally independent running bridges. It's like CGI proxy, which is a little CGI you can put up on your website and then tell your friends to use it. So the idea is some guy sets it up, and then he tells his friends about it. You can learn about it by knowing the bridge's operator, or maybe you know about it because there's somebody down the street who's using it, and you go down and you say, hey, I really need a bridge. I hope you know some. Can I learn one of yours? And the telling a friend part has some interesting incentives. The first one is, if you ask me for a bridge and I give it to you and you get it blocked, I can't use it anymore. So I really need to exercise a bit of discretion in who I tell about the bridges I know, or they're going to stop working. So that's a good incentive that we'd like. The bad part of it is you're mapping your social network for the attacker. Let's imagine that the attacker knows about some guy that they're really uncertain about, and they watch all of his connections and they learn about this bridge, and they say, oh, well, he has a bridge. And then they watch the bridge for a while, and they find 17 other people who are using that same bridge. And if the bridge knowledge was distributed by social network, then they can say, I didn't know those 18 people were friends. So that's a worry that I'm really not sure I want to use this technique in all situations. But it's a start. So this is one way that we can do discovery. And then another point is families of bridges. Rather than just having one individual bridge, let's have, maybe I run 30 different bridges, or the Linux users group in Las Vegas each runs one bridge, and they're put into one set of them. So the idea is that some of these bridges will always be available. Maybe there are 30 of them total, and maybe 10 or 20 of them will be available at any given time. Because the problem with this previous design, the independent bridge, is this guy's on Comcast somewhere, and he gets a new IP address. As far as you can tell, he's gone. Your bridge just disappeared. Now you have to use Skype or make a phone call or go back to World of Warcraft and say, so where did this guy go? Where is my bridge now? If you're using families of bridges and you've got like 30 of them, then as long as one of them is still working, then you can go back and connect to the rest, to that one or the rest of them and say, so I'm pretty sure there are 30, and I bet 20 of them have changed their IP addresses. Where are the new ones? And all of this, again, can happen automated in the background by Tor. It can say, okay, so there are 30, and there are only 3 that are left reachable. Now it's time to rebootstrap before I get cut off completely. So that's another approach that we can use. And that's probably a pretty good one. It's pretty easy to write, and it's very hard to block because nobody's going to actually keep track of that many. But let's turn it around. So what about bridges who don't know any users? And what about users who don't know any bridges? Is there some way we can allow people to volunteer without having to actually know the people who are going to be trying to relay through them? And the answer is yes, we hope. It's going to be an arms race, but I'll try to talk you through the first few steps of it. So the idea is we divide bridges based on their identity key. So all the bridges show up. There are maybe 40,000 of them, and each of them has a different identity key. We want to break them up into different pools, and each pool has a different distribution strategy, a different scarce resource that we try to make the attacker prove that he has or expended in order to learn a bridge from that pool. So the idea is that each of these strategies is different, and hopefully some of them will work. And I'll talk you through a couple of them so you know what I mean by distribution strategies. So the first one is sort of a time release thing. Between noon and 1, if you show up, we give you an answer, we give you a bridge address from this subset of the pool. And between 1 p.m. and 2 p.m., if you show up, we give it from this subset of the pool. So this means that whenever Alice shows up and says, hey, I need a bridge address, she's going to get some answer. But if the attacker wants to learn every single address in the pool, he's going to have to show up between noon and 1, and then again between 1 and 2, and then again between 2 and 3, and so on. So the ordinary user gets one answer whenever she wants, but the attacker needs to work for a long time in order to learn all of them. And it's not perfect. I hear that certain adversaries can employ people, but it'll be a start, and until it gets blocked, it'll be the really easy way to get bootstrapped. You had a question? Okay, so the question is, what's to stop the attacker from blocking the bridge authority so you can't actually get there and learn more things? So the answer is, we assume that you have bootstrapped. Once you've bootstrapped and you've got one bridge, then you can go back to the authority and you can talk to them all you like. And if you ever get to the point where you've lost all of your bridges, then I'm sorry, you have to go back and bootstrap. You have to go find another bridge, however you got around the firewall before. But once you can get around it that one time, then you can talk to the bridge authority, you can talk to the main Tor authorities, you can talk to the main Tor network, then you're in business. So it's a chicken and egg thing, but they've already solved the fact that they know how to get around their firewall. We just make it so they have to do whatever they're doing once, and now we take it from there and it's automated until they lose track of bridges and then they have to go do it again. Yes?
I have a similar question. What prevents a hacker from advertising himself as a breach? And they can take over, say, 1% of the whole Tor network. They can quickly figure out who uses Tor.
Yep. Okay, so the question is, what happens if the attacker volunteers a bridge? What happens if he says, oh, use me, use me? So the first answer is, Tor is a distributed trust network. So yes, he owns the bridge, but he also has to own the other side, or he doesn't totally win. Unfortunately, it's more complex than that, and there are a number of attacks that we do have to worry about. So the easy answer is, let's hope he doesn't do that. And in a few slides, we'll get to some more complex answers. Okay, so strategy number one is time release. That's not going to work very well, but it's at least an intuition about the sort of scarce resources we're thinking about. Another one is by IP address or network. You publish different answers depending on what IP address the requester is coming from. If they're coming from this network, then they get something from this subset. If they're coming from this network, they get something from this subset. So the idea, again, is whenever Alice shows up, there is an answer for her, whatever that answer is. But if the attacker wants to learn every answer, then he has to show up from a lot of different places around the network. And then strategy three is combine them. I look at what time it is, and I look at your IP address, and there's a deterministic answer. There's one bridge that's for you. And if you ask again during that same time slot, you get that same answer. So this means that wherever Alice is coming from and whatever time it is, there's an answer she's going to get. But if the attacker wants to learn every single answer, he has to be in a lot of different places on the internet at a lot of different times. So that's one strategy. And I don't really know how well it will work, but it seems like it might work pretty well, especially because we're already taking extra steps in the arms race. We'll find out. Another strategy is Circumventor has a trick called a mailing list. You sign up on the mailing list, they send you new bridge addresses every so often. And empirically, China blocks the addresses they send out every 3 days or so. So every 3 days they send out a new mail. It's hard to say how well this will scale. Maybe somebody would catch on and they would start blocking them every 2 days rather than 3. And then they become really popular and they start blocking them every 1 day rather than 2. I don't have any idea how quickly and how well they can start reacting to this. Maybe they'll block it within 30 seconds of sending the mail. Maybe the best they can do is 40 minutes. And at that point, you've gotten your bridge, you've bootstrapped, maybe you've learned a few more. So that's another approach we might use. It might not be perfect, but it might work. Gosh, I don't know. Or send us an email, and we'll tell you a bridge address. And we don't want to let you send a lot of emails, so we only answer once per email you send. And we want to do some sort of rate limiting, so let's implement a CAPTCHA. So you have to fill out what's in the little form, in the little picture, what letters you see. Otherwise, we don't give you an answer. And I don't want to build CAPTCHAs, so let's leave it to those great engineers at Google and Yahoo. They already rate limit for you creating new email addresses. So we only answer questions from Google and Yahoo, and we'll leave it to them to figure out how to make it hard to create 1,000 Google Gmail accounts or 1,000 Yahoo accounts. I don't know if this will work, but it's certainly worth a try. Distribution strategy